Hi guys, so now we're going to be doing some problems which are found in the book called Mind Action Series. So if you have the old version of Mind Action Series, that's where you find some challenges. The new version doesn't really have some challenges. So the old version book, you're just going to see it on your screen. That's where I got this problem here. So it's number 8, which is in page 36, right? So the problem reads as follows. It says if a squared into c minus b, a into c minus b, and b minus a forms a geometric sequence, prove that a, b, c forms an arithmetic sequence, right? So what we're going to do here is we're going to first use the geometric sequence expression here of a squared c minus b, a into c minus b, b minus a. So the properties of a geometric sequence says that if you have r, which t2 over t1 must be equals to t3 over t2, right? So by substituting those terms, so this would be term number 1, this is term number 2, this is term number 3, right? So term number 2 is a into c minus b. So let me write with a different. So term number 2 is a into c minus b all over this term number 1 here, which is a squared into c minus b, right? So if you divide out this a, divide out this a squared, we're just going to remain with 1a, right? And divide out this one here, which you'll just remain with 1 over a, right? So your r in this case is 1 over a. So let's just say r1 is equals to 1 over a, right? Let me just do that. And then r2 is equal to t3 over t2, which in this case, this is term number 3. So it's b minus a over a into c minus b, right? And yeah, we can't simplify it further. So we're just going to leave it like that, b minus a over a into c minus b, right? So let's just say this is another expression of r. This is the first expression of r. So r1 must be equals to r2, right? The ratios must be the same, of which r1 is 1 over a, right? So it's going to be 1 over a is equals to b minus a over a into c minus b, right? So I'm just going to do a cross multiplication, but this cross multiplication, I'm just going to multiply this expression to this one here, and then multiply this a that side. So we're going to have a into c minus b is equals to a into b minus a, right? And what you'll have here is this a will divide out this a, so c minus b is equals to b minus a, right? So this is the first expression that we are getting from the geometric sequence, right? So now let's go to the arithmetic sequence. So the arithmetic sequence, we are given a, we are given b, we are given c, and we are told that we must prove that it's an arithmetic sequence. So an arithmetic sequence is defined by a common difference, right? So whereby we have b minus a and c minus b, right? So this is a difference where t1, t2, and t3 here. So term number 2 minus term number 1 term number 3 minus term number 2. So this is what I'm getting here, that the common difference is b minus a and c minus b, of which, if you remember clearly, in our arithmetic sequence, we got c minus a being equals to b minus a. So therefore, from our geometric sequence, we got c minus b being equals to b minus a, right? And in our arithmetic sequence a, b, and c, we are finding that b minus a is equals to c minus b, right? So for the mere fact that we are getting this difference here, which is common, right? Which is common, therefore it concludes that our a, b, and c is definitely an arithmetic sequence. Hope we understood in solving this problem. If you have any questions, please comment down below. Thank you.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.